Welcome to one of the last sessions of WNE 2025 here in Paris. I say before every panel, this is my favorite, but this is really for sure my favorite. I promise you. AI in nuclear. This is going to be interesting, and followed by a really interesting panel, the last one for today that we wrap up at 4. So please join us for the second one as well. But now get ready. They are here, the great speakers, and we have a great moderator coming up. Vincent Champain, welcome up, Chief IT and Digital Officer at Framatome. Give him a warm hand. Looking forward to this. Thank you.
Thank you very much. Very happy to be here. Today we'll tell you about AI for nuclear, but for this I will call my guest speaker. So first, Anne-Cécile Dagorn. Anne-Charlotte. So Anne-Charlotte is the VP North America for Assystem. Then Aurélien Schwartz. Aurélien is the CEO of Metroscope, a database company working for nuclear. Then Christopher Eckerberg. Christopher is a member of Google Western Europe in charge of data centers. Then Ayadi Benmeki. Benmeki is working at ASNR, the French regulation authority on AI. And last but not least, Michael Fleming. Michael is head of data, bank, and head of IT for the Nuclear Energy Agency. Thank you very much. So, first, I would like to turn to Anne-Charlotte and Aurélien. What's interesting, what would be interesting for us is the precise, concrete example of how AI is changing nuclear today. So what are the cases you see on the ground? Maybe Anne-Charlotte first.
Yeah, sure. So today we see 3 main type of use cases where using AI is already delivering tangible results. The first one is around automation. So we've created a platform called Smart Compliance, which is using AI, system engineering, digital twin, to free engineers from probably the most time-consuming task in nuclear engineering, which is producing, managing requirements and proof of compliance across thousands of documents on large projects. So we're using AI across different stages of the process to extract and classify requirements, to generate justification, and to automate the analysis of compliance with technical standards. We're now doing the same on 3D models, on drawings, and so basically what used to take up to 16 hours is now done with the same quality in 2 hours. So Assystem, as an owner engineer, we are focusing on delivering the project. So using AI to free engineers from just producing, classifying documentation to work on tasks that are actually pushing projects forward is critical. Second example is around turning data into decisions. We've created a tool called Optimizio, an AI planification tool that we are deploying with EDF on outages. So basically, it takes all of your parameters, all of your constraints, logistics, available resources, site and reactors situations, and it produces the outage plan in less than a minute, really. What's interesting is that a traditional outage team would do the same in 1 to 3 months with the same results. And finally, beyond productivity, what I want to highlight is how we are using AI to transfer knowledge. Looking at all the new build programs that we have in front of us, transferring knowledge to the next generation or to a project to another one will be critical. And so we've produced a tool called Digital Learning from Experience that takes 60 years of know-how that we have at Assystem, expert interviews, project lesson learned into a knowledge searchable database so that our engineers have an IT chatbot that they can just use on a daily basis to get the information they need when they need it.
Thank you very much. Maybe I will turn to Aurélien. So Aurélien, very different size of company, more data-based. What are the really killing examples you see on the ground for nuclear?
Thank you, Vincent. So yeah, indeed, Metroscope, we were born 8 years ago out of a technology. And the aim of Metroscope is to protect the availability and the performance of the nuclear power plants. So all our examples are very concrete. We only have use cases, actually, among which we already oversee the generation of the 56 nuclear plants of EDF in France, but we also are all across the world in more than 10 countries differently. So what is it that we do? What we're doing is we're building a diagnostic to support the operators in understanding what's happening on the process. So let me do a quick detour about the technology so people understand what we speak about when we speak about AI. The AI of Metroscope is you have data on your plants, okay. You need to understand what is the status of every equipment on the plant to take the best decision to better operate or better maintain the plants. What we do is we take all that information and we run our algorithm and we feed them with prior knowledge of everything that can go wrong on the plant. Then we play thousands of scenarios until we find the one scenario that says, this is what we think is happening with the highest reliability possible. And you want concrete example, the most meaningful example I have right now is what we did yesterday, right on WNE. We did an announcement with Energoatom, so the Ukrainian nuclear operator, because we will be supporting the Ukrainian operation on the Rivne nuclear power plant. Our goal is to find 10 megawatts of free electricity on one unit of Rivne nuclear power plant. It means that the AI of Metroscope will soon provide electricity to 40,000 Ukrainian homes. So this is very real, Vincent.
That's very clear. Maybe turning back to Anne-Charlotte. Now, if you look further, how do you see the big change? How do you see the nuclear reactor in 2040, maybe 15 years from here, working very differently using AI? How will they look for you?
Well, you know, seeing the speed at which AI is progressing, imagining what we'll have in terms of technical capabilities by 2040 is almost hard to imagine. I mean, the computational power of AI has been doubling every 6 months for the past decade. So, you know, from a pure technological point of view, sky is the limit, really. Now, if we look at projects timeline, you know, Assystem, we work on new build projects across the globe. So when we look at programs in the US, in India, in France, 2040 is when we'll have the first unit in operation. And so the big stake will be repeatability. So as owner engineer, what we expect from AI is that it will really, you know, facilitate and speed up the way we build a unit to the other one so that we can leverage the serial effect. So one thing, you know, that will happen is probably AI-driven digital twins that, on the one hand, will facilitate the transfer of information, of data, of lesson learned from a unit to another so that we can go faster on design review, on test and commissioning. But at the same time, they will also, you know, improve operation because instead of the digital twin that we have today that are still static models, with AI-driven digital twin, what we'll have are living systems and representation of the plans that do not only simulate, but that really suggest, anticipate, and optimize cost, safety, performance for the engineers. But I think that beyond these technological possibilities, it also raises questions. I think by 2040, we also need to find the right balance to make sure that AI reinforces, but do not replace expert knowledge. Because, you know, performance is important, but in the nuclear industry, safety is key. And so we need to make sure, you know, that our experts stay skilled, empowered, and accountable. So, for instance, yes, AI will free engineers from time on, you know, low added value tasks. But young engineers especially, they also learn from doing this task early in their career. And so, you know, if we embed AI too fast, too much, don't we risk to, you know, threaten this learning curve? I think it also raises questions about governance. Again, looking at the power of AI by 2040, who will have the legitimacy and the confidence to challenge the AI system if it reaches a different conclusion than an expert? So all these questions depend on the choices that we'll make as an industry. Is AI a fantastic opportunity that we must embrace? Absolutely yes, but we shouldn't look at it only from a technological perspective.
Thank you. So we'll be very different. Now, Aurélien, you are a digital native company and you were created in the internet. I'm pretty sure that when you visit your customers that have a lot of legacy, you would see things very differently if they were started from the beginning. So how do you see this 2040 reactor working with digital?
Yes, so Vincent, I think you share that reality that the data is scattered all over the place and technology is not enough. And I totally agree with you and Charlotte. The technology is getting at least strong enough to achieve 90% of what we think AI is able to do in the short term. Speaking for Metroscope, I have my technical staff in the room, and I will speak on their behalf. We think that between 5 to 10 years from now, we'll be able to diagnose 90% of what's happening on a nuclear plant with high reliability. This is not the problem anymore. The problem is accessing the data, of course. And then the question, because your question is, what is it in 2040? The question is, how does it shape the organization? What will it bring to the organization? And the way I see it is, right now, if you look at Metroscope, people using it are essentially on plant. Like there are site engineers that need to know what is the status of the plant and operate. What is it going to happen tomorrow? Tomorrow you will have the site operator, but you will have the support engineers, you will have the OEM, and you know about that because Framatome is a partner of Metroscope, bringing that expertise of original equipment manufacturer to the operators that we're working with, but also the data scientist is using the same platform, but also the corporate people who have to do the long-term maintenance planning will use the same data and the same platform, and that encompasses the concept of single source of truth. And what is it that AI will bring by 2040? It will behave as a single source of truth across the whole organization. Everybody who needs an information will know exactly where to find it. It will be unbiased. It will be reliable. Then the question is, what do we do with that?
That's a good question. And Charlotte, if there was one thing to change to accelerate this journey to digital, what do you think it would be?
Well, I have 3 things, but I promise I'll be on time. So for me, there are 3 key things that we need to change or progress on if we want to leverage AI at scale. The first one is collaboration. I mean, we all know that beyond any good AI system is good data. And so, you know, not one single company, not even the biggest operator today has all the data that we need. So that means that we need more collaboration, more data sharing across the entire nuclear value chain. So from regulators to operators, OEM, and suppliers. But of course, if we are to share data, we need to do it safely. And that brings me to my second point. We need, you know, safe, sovereign, cloud infra that enables us to share data and guarantee cybersecurity and sovereignty if we are to collaborate more across the value chain. I think you know, different initiatives such as the Secnum Cloud in France, so this framework created by ANSSI, the National Cybersecurity Agency, are going in the right direction, but clearly, if we want AI to be this big disruption that we are waiting on, we need to stop working in silos, collaborate across the industry so that we use AI not only on one project or within one company, but across the entire ecosystem. And my last point, again, is that we also need to work to implement the right governance and culture of trust. You know, beyond technology, we need to adapt our governance, we need to adapt our culture, because explainability and human in the loop must be ensured at every step of any AI process. So that means clear rules on who validates what, how results are reviewed, and what level of transparency are we expecting before any AI recommendation is taken into consideration. And I think that means also training the team so that they understand the system and they feel confident to challenge it when something doesn't feel right. So collaboration, safe and sovereign data cloud, and a governance that guarantees human in the loop and explainability.
Thank you very much. And for you, Aurélien, what are the advices you would give to your much bigger customers?
First, I subscribe to everything you said, and Charlotte, so I won't repeat it. And that makes me really glad that we signed yesterday a memorandum of understanding with Assystem, because I can really see where this is going. To my big customers, I would say it is really important to educate yourself to what is a product versus what is a technology, to cybersecurity, in the cloud, because that is of major importance if you want to benefit from the best technology available. That won't happen on private data centers. I don't think so. So that would be just my additional point. But for the rest, I'm very much aligned with what you said, Charlotte.
Thank you very much. So we'll turn to a much bigger company, Google. Christopher, how you see nuclear energy from a hyperscaler point of view? I mean, what will your future energy needs be, and how might nuclear fit their needs?
Thank you, and thank you for the invitation to be here as well. Well, as you know, Google is already a very large energy buyer. We buy about 25 terawatt hours a year. And typically, one of our promises to our customers is that we buy clean energy for all of the data centers and networks that power the stuff we do. And so far, up until a few years ago, our promise was to match renewable energy purchases with our consumption. But we realized that that's not enough. And what we want to do now is actually find carbon-free energy for all of our energy consumption and match it on a 24/7 basis. And we realize that that cannot be done without nuclear, at least not in all markets. And so nuclear has become a more important part of Google's energy portfolio. And we're looking at ways to support the development of both new and existing technologies. Just one example, last year we announced a partnership with Kairos Power, the developer of a molten salt reactor, and committed to buying 500 megawatts from their reactors as they develop them. And actually just earlier this year, we announced the first location for the demonstration plant, which is in Tennessee at Oak Ridge. And we expect the first plant to actually deliver power to the grid already in 2030. Optimistic, but achievable, we believe. So that's really exciting. That's one way we can support new technology development. Another really exciting piece of news, which many here probably have heard already, just a few weeks ago, we announced a deal with NextEra Energy in Iowa to enable the restart of the Duane Arnold plant, which is a 600 megawatt reactor, which has been shut down since 2020. And so with a power purchase agreement that Google has signed, NextEra Energy can make the investment to restart the plant. The plan is to get it back online in 2029 and delivering 600 megawatts of clean energy to the grid. And this is really important for Google. We come to these states, for example, Tennessee or Iowa, where we invest a lot in digital infrastructure, we consume a lot of energy, and so we feel it's important to also contribute to the development of new clean energy sources, and nuclear is a key part of that.
So very interesting, and we can't just wait to see you making such a big deal in France with EDF. So let's hope. Now, Google is also a big AI company, one of the companies having the biggest AI model in the world. And it would be interesting to know how you think AI can change our industry, viewed from a technology expert.
Well, I think some of the examples that I have are quite similar to what Anne-Charlotte and Aurélien described. I mean, Google is obviously involved in such a broad range of spectrum of AI development. We have Google DeepMind, which is our scientific research arm. These are the guys who get the Nobel Prize, and so my explanation of what they're actually doing is not going to give justice. But one example of a partnership that we presented just recently is with Commonwealth Fusion Systems. They're developing a fusion reactor. And here I realize I'm on thin ice. There probably be people who know much more about this. But one of the challenges with fusion reactors is controlling the plasma with magnets and you know, steering it. And what DeepMind's technology is helping CFS do using this deep reinforcement learning is three things. One, to make better simulations, so planning the work and the design. Also, number two, maximizing the energy output from this process, the fusion energy. And third, very sort of hands-on, controlling these magnets in operation, because it requires very, very advanced steering, and that's where technology like DeepMinds can come in and support the actual operation. Another much more hands-on example is a deal that Google Cloud did with Westinghouse. We announced it this summer. It's using Google's AI a bit more sort of actually applying it to project management. So this is hands-on in large construction projects where our technology was then trained with the experience from construction projects. Just like you say, some things go wrong, some things go right. With all of that knowledge, these tools can actually optimize project. You break down the work packages into small tasks, replan them and optimize them through simulations to actually get a much more efficient planning, taking time and budget off large construction projects. And it turns out that even the most experienced project manager cannot do those tasks without these tools. And so this is very useful support for the project management teams in construction projects. So I think there's so many different ways that AI is going to affect the nuclear industry, just like all of our industries in the world. Yeah.
Thank you. And maybe one last question. It's not necessarily very clear what your positioning will be in energy. So will you be customer of utilities, or will you invest in your own reactor? Because we're hearing a lot of communication. It's not necessarily very clear.
Well, I mean, typically what Google likes to do is procure power, to be a power customer. We believe there are a lot of companies that are much better at operating plants than we are, and this is also in conventional and renewable energy. Typically, we leave that role to the developers and the utilities, and we will be a customer. So in the example of Oak Ridge with Kairos Power, we're actually buying the power from the TVA, the Tennessee Valley Authority, which is the local utility. Kairos is delivering the power onto the grid. So we're simply a regular grid customer with a long-term PPA there. And that's typically the role we believe is the way we can best support this industry going forward. Yeah. Thank you very much. Very clear. Maybe, so we talked a lot about data. Maybe I will turn to Michael and from the NEA. So you're in charge of the data bank of NEA. I'm not sure people know what it is. Maybe you can explain us. And maybe my first question will be, what breakthrough do you identify today that could change the way we build and operate reactor leveraging data?
Thank you, Vincent. So I work for an international organization, and I have nothing to sell you today. And instead, I give you a bit of a perspective as an observer that interacts with regulators and vendors and operators in multiple countries. And I also want to reiterate some of the points that were made by our earlier speakers. I'm responsible for the data bank at the NEA, where we host data in a collaborative fashion and put together international benchmarks that are used for verification and validation before safety authorities. And the key driver that we see in the next years is data centrality. So for all the operators, for all the vendors, it has been a talking point that people say digital twins. But this might be an afterthought. And they think to themselves, I can put a bunch of reports, a bunch of other assets in a data lake and hope that some AI engineer is going to come up with some insights. And this is backwards. Maybe we don't need to go to the extent of being a data company that happens to build reactors, but if you take that sort of mindset, you'll approach the sort of direction that we see many companies moving into. Another key point that I want to reiterate is that a lot of AI is not going to be done on-prem. It's going to be done using Google, it's going to be used in AWS, it's going to be using Azure. And compliance, export control regulations, the ability to use those tools is going to be extremely important. And also for the business development, being able to help consumers reach their compliance goals is essential moving forward. And then the most important, reiterating the comment made earlier, point is that transparency, explainability are essential for trust. The nuclear industry moves at the speed of confidence. It is not going to move faster with its innovation. It's not going to take an AI's advice and supplant experts. So the ability for you to go in front of the regulator and explain how that was done and explain why it is relevant and provide the benchmarks and validation cases is going to be essential for trust in breaching the next barrier to the regulator.
Thank you very much. Very clear. So there was an announcement yesterday by EDF on a platform called Data for Nuclear, which is a platform made to share data in the extended enterprise around the EDF reactors. How do you see data exchange evolving in the future? I mean, how can TSO, researchers, vendors, operators contribute? And how can this contribution be, I would say, cross-country?
This is a really prescient point. So collection of quality data is the essential building block for all of this work. And it's not just about quantity, although quantity has a quality of its own, but it's about international peer review with experts and putting together trusted data sets in an international context, especially if you want to export your technology to another country. You're not going to talk to one regulator. You're going to have to speak Japanese, and you're going to have to be able to interact with the French as well as the Americans, potentially, depending on what your business cases are. If you want to achieve that, you can use the international community. You can have projects like the Halden Reactor project. So we've done this for 60 years. We establish one trusted center. We do some dirty experiments for many different customers. And we can establish an international consensus on what quality data you can use for your applications. The NEA is launching an initiative in this front as well, called the AI Expertise Project, which seeks to bring together all stakeholders, ranging from the research community, including regulators, including operators, including vendors, to put together a set of rigorously peer-reviewed data sets and benchmark validation cases for us to be able to have complete explainability and transparency about how that was conducted so that you can take it to the regulator.
So very clear. I didn't mention it, but before joining NEA, you were also a UK regulator in charge of fusion. Maybe last question, how is the current state of this data exchange between regulators today? And then I will ask Ben Meki the same question.
It is a very tricky question. We operate several fora for exchanges between regulators like the CSNI and CNRA, and maybe you know my colleague Véronique Royer. This is a continuing project. It's not something that is solved in a short period of time, but it's only through mutual understanding and the creation of benchmarks that can be understood by multiple cultures that we can reach that sort of consensus between different regulators. And for more information about that, I'm happy to talk with people. We have multiple joint undertakings which involve multiple countries and different clients in the creation of experiments in a broad range of areas for them to establish mutual trust.
Thank you very much. Now turning to Ben Meki-Ayadi. So you're in charge of AI at the French nuclear regulator. Maybe I will start with the question. As a regulatory authority, how do you see the AI revolution? How is it changing your activity today?
Thank you, Vincent. Many of them have been presented yet before. I will only focus on one issue, on data issue. The main evolution for us is the shift from document-centric to data-centric practices. The volume and complexity of data continue to increase, and the priority is now to export information more efficiently and consistently. We see coming three complementaries of direction for that. The use of AI to support navigation and exploitation of large and multimodal data sets, and the use of digital technical evidence supported by PLM environments or digital twins with predictive models like Saeb, my colleague here. And the development of data hubs, also between regulatory bodies and the nuclear industry to improve the efficiency of licensing.
So, thank you. And, but if we really focus on the way the authority is working or the international collaboration,
yeah.
So what's the state today and how do you see evolving in the future, and maybe how regulated companies should evolve to that?
Thank you, Vincent. First, at ASNR, we launched several years ago a business-driven program called Expertise Augmented, designed to anticipate and prepare the use of AI in nuclear field. It is structured around three main axes of potential of use of AI. First, the use of AI in operational context, like we can see here, and the AI to support safety demonstration and the AI to enhance safety assessments. The objective is to better understand the implications of AI on safety and to anticipate the changes that AI may bring to our technical practices and the potential evolution of regulatory framework itself at the right time, not now. And we are also working on a white paper with some of them, some industries, and to support this work, we work with nuclear industries to share perspective, identify use case, and jointly clarify key issues. We are also working on white paper with some of industries, which the publication is planned for the next year. And at the international level, we collaborate with regulatory authorities like NRC or TSO, both like GRS, and through international initiatives. For example, we contribute on ongoing AI tech doc on safety and security AI impacts, and we participate on regulatory sandboxing activities led by NEA. Thank you.
Thank you very much. So maybe I'll have a larger question and coming back to Aurélien. How do you see the skills and talent equation? Because I mean, today AI talents are courtised a lot. I mean, Google knows about this. We're in an industry, a relatively frugal industry. So how do you see the challenge, and maybe what do you think the industry could do to make this challenge easier?
If I look at the business model of a company like Metroscope, software editing startup, we recruit designers, we recruit product managers, we recruit customer success managers, we recruit JavaScript developers, we recruit Python developers, data scientists. All those skills are not very natural for the utility to develop because they, and that's normal, they have expertise on their field. They have people in charge of neutronics, thermodynamics, stuff like that. We do also have that, because if we don't understand them, we're not able to work with them. But when it comes to product development, there's a whole range of skills that needs to be taken care of, needs to be recruited, even in utilities. I've seen so many big companies telling like, oh yeah, of course I can make a product. No, what they can do is a Python script that gives you the right answer, provided you are the Python developer. Okay, but you're not going far with that. You need the guy who is in charge of the cloud. You need the guy in charge of the cybersecurity. You need the guy in charge of the design. You need the guy in charge of the user experience. That is the whole ecosystem that you need to build and embrace if you want to be serious about embracing the cloud, on top of what you're already doing, by the way. And so you asked me earlier what would be my recommendation to big utilities. I think there's a lot of education that still needs to be provided for everybody to understand what is this new skill set that we need when we're thinking about AI. And that is on the software editor side. But then, as a user, you also need to develop new set of skills to have the ability to use AI, understand what you're seeing, and being able to take real decision out of that. And here, we see a big generational gap right now. It's happening right now. If I'm bringing Metroscope to a utility with people that have been there for like 30 years, they will tell you, I don't want that. Like, I like what I used to have. I like my Excel file. I like my manual upload. You're changing the way I work too much, too deep. I'm not getting there. And you have the new generation, and they're like, whoa, I don't even have to learn how a nuclear plant works. That's not a good answer either. That's not a good answer either. So you need to find the balance. So there's a lot to do on the skill sets, I can tell you.
Okay, will do. And Charlotte, you're in a service company, so you hire a lot. Do you see any specificity on these AI talents? And if so, what do you think the industry might do to be more attractive to these talents?
Well, I think, if we kind of, broaden the question to attracting more talents, because of course you'll need specific skills for AI, but I mean, generally speaking, the nuclear industry needs more engineers and more talents, and we have a real problem of quantity. There is a shortage of engineers. Of course, we can do more to be more attractive, to encourage, people, young people to go in data scientist program, engineering program. But I think we should see it also the other way around, and that brings us to the beginning of the table, is to say, how can we use AI to work more efficiently, because we can do whatever we need to attract and multiply the number of engineers, but at the end of the day, when you look the number of nuclear programs in front of us, that won't be enough. There's no way. And so using AI to make sure that the engineers that we have are working on high-value tasks and being more efficient, so that tasks that would take, again, 16 hours before to review compliance, or 3 months to come up with the best planification that now we do under a minute, is a way to address this shortage of skills. So I think there's a real virtuous relations between AI and talents hunt, so to speak.
Thank you very much. So Christopher, I think you're a good example for that, because you worked for Vattenfall. Now you're working for Google. So what are the differences you saw, and maybe what are the advice you would give us so that we have as many people hired from Google in Vattenfall than from Vattenfall in Google?
That's a great question. Well, I was personally attracted to, Google as a big investor in new energy, coming from an energy background, of course. One thing I really think that the utility industry has to do, and the nuclear industry has to do, is use the momentum of the new build programs that are going along. For many, many years, and I'm looking at Sweden as an example, where I'm based. The nuclear industry was seen as something that, okay, we'll run these plants that we have until the end of life, but nothing new is going to happen. What we've seen now with the new build programs being planned and discussed and becoming much more real in the Swedish society is that young students, but also people from other industries, are now looking at the nuclear sector as an interesting place to work, where there's a future, there's new technology, a lot of investment going into that industry. And so I think also the plants that are in operation today can actually get a boost of interest for the nuclear sector thanks to the new build program. So really build on that momentum that's coming. I think it's very important to show that nuclear is also, a future-oriented industry, and not just running old plants from the 80s. Yeah.
Thank you very much. Ben Meki, if we consider the nuclear authorities, first, how you see this talent equation, because it's probably not easy for you either. And secondly, what are the other challenges you see to develop AI and technology in this industry?
Thank you. I will respond on the second question first. And as authority, the key challenge is trust and the alignment with nuclear safety and security requirements. Because AI is based on data and non-deterministic approach, and while our sector relies on physical models and formal explanations. For example, these are challenges of the verifications, validations, and qualification of AI-based systems, as well as interpretability and explainability of models. And the key point for us is the preserved expert judgment at the center of decision-making. And to make the link with the competence, I think the most of them is to be for the engineer safety to increase their level on data science to be as sufficient critical on the response of AI system.
Thank you very much. Very clear. Michael, finally with you. So you talked a lot about sharing data. So people only share data when they trust each other. What are the trust issues you see today in the industry, and what do you think we should do to improve them?
Thank you. I take liberty to also address this education question very briefly. Sure. There are many companies that are building new AI technologies that can pay well, and they can attract this talent, and they can make a really interesting product. And this question comes to others where we have open-ended contracts and inertia in its HR practices, and it seems to be a challenge. And these companies we see are faced with the problem of, do I outsource it? Do I try to make a spear tip team inside my organization? How can I address this problem? And there's an unsaid important culture issue of, do my people that do reactor physics have the inability to do Python and learn a bit of PyTorch? Because I promise you, it doesn't take that much effort, and we've got really clever people in every organization, all the way from the operators to regulators, TSOs, everywhere. Those people are able to be upskilled. AI is not taking your job. You're going to take AI on board, and you're going to be able to make yourself into a more proficient, capable person, being able to take jobs that used to take 16 hours and turn them into 2-hour tasks. It's not all chatbots. You can learn Python and endpoints and SDKs, I promise you. I hope that sort of message can be taken forward to all the organizations in the nuclear sector. And regarding data trust, the most important aspect of trust in data is that everybody has a hand in the evaluation and that you trust the experts that are looking at it, and that you have a representative from your country that you have a close relationship with, that you can leverage that trust relationship for them to say, yes, you trust this data. So it's important for you to participate in international collaboration. It's important for your experts from your laboratories, from your TSOs, from other organizations to participate, to validate that data, and then you can use that for your business case.
Thank you very much. Very clear. So I think we all align on the fact that the potential for AI and data is big. That for that, we need energy, but we're happy to provide it to you, Christopher. And that for that also we need talents and trust, and also working, of course, seamlessly with authorities, and also maybe having more coherence between the industrial or regulatory frameworks along the world. And AI and data sharing will for sure help us for that. Thank you very much. We might take 1 or 2 questions if there are in the room.
Thank you very much for this brilliant panel. Got a lot of questions, a lot of things to say, but maybe I will focus just on 2 questions. The first one, we've seen from Google and Google DeepMind some paper on Nature. I think it was on fusion and plasma control, etc. So first question, what has been done after this paper, and were there any connection with ITER or any other organization which is working on fusion? And the second one is to the 3 guys on the left on regulatory and cloud. How do you see the compliance of the cloud for nuclear and also the nuclear safety demonstration on architecture? Will we have, like we do on the conception of plants, the redundancies, the different defense in depths that we've got for architecture to prove that the safety demonstration is good, and also obviously on the AI models? Thank you.
Well, on the first question, I'm really sorry, but the answer is I don't know. So I'm going to have to pass on that one, but I can look it up and get back to you.
I can try a response for the high licensing. The authorization of a system of safety-related functions is not under considerations today, due to open issue challenge of regarding our robustness, exploitability, and more. The first of them is safety alignment. Our priority to ensure that any use of AI remains compatible with safety principles, which rely on physical models and structural augmentation. You say so, the safety demonstration. And now at IUSNR, you have to make some work on the compliance of AI acts in Europe, not only to make a nuclear sector-specific gap analysis to identify the implications of a nuclear field in regard of the safety requirements framework.
Thank you. Maybe one last question. No question? Okay. Thank you very much. Have a great day.
Thank you so much for this panel. Great, and thank you for the questions. Give them a warm hand. We only have one more panel to go now, and I hope you're staying, because this will be soon, it will be the last panel of the day before we wrap up, and I hope to see some of you, of course, 2027 as well. We're going to actually, at 3 o'clock, we're going to have a panel discussion on the nuclear energy and the climate equation. So that's going to be focused on nuclear and climate. So please come back at 3 o'clock. See you then and enjoy the break. Thank you.